Today we're going to be talking about solving using addition or subtraction. And our essential question for today is, how can I use inverse operations to solve equations? And I'll be telling you throughout what you should be writing in your notes and when I'm just kind of giving examples to make you understand. So for right now, you don't have to write anything yet. So what we've been doing up until now is we've just been simplifying. We've done the distributive property, we've combined like terms using boxes and circles, and we've also factored so that our answer looks like the distributive property, but we never find out what does x equal or what does y equal. We only find out how to simplify an expression. So today is when we're actually going to start solving. So we're going to talk about what an equation means. And an equation is a statement that says that both sides of the equal sign have the same value. And there's a key word, same value. They don't necessarily look the same, but they have the same value. So let me show you some examples. Right here, and again, you're not writing these down, you have 3 plus 4, and that does equal 7, which is on the other side of the equal sign. They have the same value, but they don't look the same, and they don't have to. An equation is just saying that they have the same value. So this has the same value as this. 9 times 9 has the same value as 81. So it doesn't have to say, an equation doesn't have to look like 7 equals 7 or 81 equals 81. They just have to have the same value. If I do 2 plus 4, that's 6 minus 7 equals -1. Again, they don't look the same, but they have the same value. Here, this is saying that 3 times some number plus 5 is the same as 6. We just don't know what that x equals. Here, this is saying some number plus 7 equals 45. And maybe some of you can use some mental math there to say, oh, the number's 38. So if I replace that with 38 plus 7, that is the same as 45. Again, they don't have to look the same. It's just about having the same value. Now, a lot of the way you learn this is, or in like 5th grade and 6th grade, is that you have to keep an equation balanced. What that means is what you do to one side, you have to do to the other. So let me give you an example, kind of something we've done with this before. When we were adding and subtracting fractions, let's pretend, again, you're not writing this down, let's pretend I had 4/5 plus 6/9. Well, they have to have a common denominator. Here, you would multiply 4 times 5 and get 45. But what I told you guys is you can't just say, I don't like this 5, I'm going to change it to a 45 and just bring my 4 over. That's not the same. What you could do is, for example, on this bottom one, I could do 9 times 5 to get 45, but I'd have to do the same thing to the top number to keep it balanced. If I multiply the top by 5, I have to multiply the bottom by 5. If I multiply this bottom here by 9, then I have to do the same thing here to get me 36. You can't just change the denominator because you don't like it. Same thing here. You can't just change the equation on one side because you don't like what it says. If you change something to the right-hand side, you have to change it in the exact same way to the other side. The reason I say the exact same way, so you'll see later that we're going to be adding to each side or we're going to be subtracting to each side. If you subtract to one side, you have to subtract to the other. If you add to one, you have to add to the other. I would never do this. I would never say, well, I'm going to multiply this by 5, but I'm going to divide this by 5. That wouldn't work either. If you multiply the bottom by 5, you have to multiply the top by 5. So here, if you add 5 to one side, you have to add 5 to the other side to keep it balanced. What the terminology that I use here instead of keeping it balanced is a lot of times I refer to a mirror. And later on, you're gonna see why. But let me kind of erase everything that I have here. Let's take an equation, a simple equation, like x plus 4 equals 6. This is saying basically that some number, we don't know what it is, some number plus 4 equals 6. Now, a lot of you thinking that's easy. That's just 2, because 2 plus 4 equals 6. So some of these are mental math. We could do them very simply. Most of the ones we're going to be doing aren't mental math. So we have to have a way of doing this for any problem that works for no matter what it looks like. For example, if I had this is again saying some number plus 16/11 equals 6. That's not so easy. We can't really do that using mental math. So we need to have a way of doing this no matter what the problem looks like. So today you might see some that you could do mental math, and you're going to see some that aren't. So for your notes, I want you to make sure to write it the way that I'm writing it, to do the steps the way that I'm doing it, because that way you can apply this to anything, to any of these equations. Remember, notes are all about the process. So in your notes, if all you have is the equation and the answer, it doesn't help us to know how you got that answer. So if you look at these notes a month later, you should still be able to tell how we got the answer. So make sure that when we get to examples, you're writing everything down. So we're going to talk about what's an easier way of doing this, because that's not to be done easily using mental math. Okay, so this part does go in your notes. This right here in your notes at the very top, it says vocabulary review, and the first word is inverse properties. Operations that undo each other. And I want you to make that list. Addition and subtraction, they undo each other. Multiplication and division, they undo each other. So I want you to pause the video, and I want you to take a second to write that down for the vocabulary words. Okay, that should have been enough time. Now I'm going to kind of explain why they are inverses of each other. This part you do not write down. This is not going in your notes. I'm just showing you why these are inverses of each other. They undo each other. So let's say that I started with 6. If I had 6 and I added 5, that would give me 11. If then I did the inverse of adding 5 and instead I subtracted 5, well, 11 minus 5 equals 6. And I end up right where I started. Adding 5 and then subtracted 5, they undid each other. If instead I had 6 minus 1, that equals 5. And then I do the inverse of subtracting 1 and instead I add 1, I'm going to end up back where I started at 6. So that shows you that adding and subtracting undo each other. If I add something and then take it away, I'm where I started. If I have 5 and I want to get rid of it, I subtract 5. If I'm missing 10 and then I add 10, that undoes that. And same with multiplying and dividing. Let me show you some completely different numbers. If I have 7 and I times it by 5, that gives me 35. Well, if I take that same 35 and I divide it by 5, I end back at 7. It undid what I just did. I multiplied something, and to undo it, I divided it. Let's say I have 8 divided by 4. That is 2. Now I want to undo that. To undo dividing 4, I'm going to multiply by 4, and that gives me 8. So again, you really, really need to know. Adding and subtracting undo each other. The inverse of adding is subtracting. The inverse of subtracting is adding. We'll focus on multiplying and dividing later this week, but for today, it's adding and subtracting. Okay, this part does go in your notes. So go ahead and pause the video and write that in the vocabulary review for the word isolate. Okay, to isolate something means to get the variable alone. So imagine that you feel very isolated. That means you feel alone. So for example, you don't have to write this down. If I had 3x plus 6 equals 30, that x is not alone. It's being multiplied by 3, and then it's having 6 added to it. We don't want that. That is not isolated. The whole point of solving is to get that one by itself. What I want to know that x equals 8. And you don't have to know how I got that right now, but we want it to look in this form. We want x by itself. So that means we'd have to get rid of this plus 6, and we'd have to get rid of the 3. we want it by itself. The whole point of doing this is to isolate. So a common mistake that people make is that instead of moving the 6 to get rid of it, they bring the 30 over to the left-hand side. That's not going to get x by itself anymore. It's not going to help. We want to get rid of the 6. We want to get rid of the 3. So make sure that whenever you're doing this, you're getting rid of whatever is with the x. Even if I wrote this backwards, if I wrote 30 equals 3x plus 6, instead of moving stuff to the right-hand side, now we're going to be moving it to the left-hand side. Again, the point is to get x by itself, to isolate it. Okay, go ahead and write step 1 down. Step 1 is to draw a mirror. The reason I use the example of a mirror is a reflection. So if you're looking in the mirror and you're raising your right hand, then your reflection is raising its right hand. If you are shaking your left foot, then in the mirror, your reflection is shaking its left foot. So it's to remind you to keep a balance, that what you do to one side needs to be reflected on the other side of the equal sign. If you add 5 to one side, you add 5 to the other. If you subtract 0.6, then you subtract 0.6 from the other side. If you're moving your right hand, the mirror is not going to show that you're shaking your left foot. You can't add 6 to one side but subtract it from the other side. They have to be a reflection. It has to be the exact same thing. So that's what I mean when I say draw a mirror. Okay, step 2. Do inverse of constant to both sides to isolate the variable. So inverse operations. Here, that is addition or subtraction. Remember, those are inverses of each other. Constant, maybe you need to write yourself a note there. That means that there is no variable. The constant is the one with no variable. So think of it as you're in a group of friends and one of them is being really, really annoying. He's constantly bugging you. So the first thing you would do if you had to get rid of a friend, like at this party, like, you know, there's too many people there, you would get rid of the friend that's constantly annoying you first. Or maybe your sibling that's constantly annoying you first. The constant, the one with no variable, that's what you're getting rid of. And you're going to do it to both sides in order to get that variable by itself. And then step 3 is to check your answer. Part of what makes math difficult sometimes is you don't know if you have the right answer. You just, you put 2/5 as your answer and you just pray that it's right. And then you put check answer like 500 times in big ideas and you don't know what you did wrong. Here's what I love about solving equations is you can check every single time if you got it right. And you will know without having to put check answer, without having to ask me if you got it right. You'll know because you can check your answer here. That's what's awesome about it. If you still need more time to write those down, go ahead and press the pause button and finish writing those steps. Okay, make sure you wrote that in the steps box. Example 1, make sure you're writing this goes in your notes. Okay, this goes in example 1. Go ahead and write x minus 6 equals -1. Now I understand, like I said before, some of you could do this mental math and that's fine. I still want you to learn the process because by the end, just in the next few minutes, you're going to get ones that are not mental math. So write everything that I'm writing, write yourself the little notes. Again, the notes are all about the process. So here, let's first think about what this is saying. This is saying that some number minus 6 is going to equal -1. So I'm going to do step 1. I'm going to draw my mirror. All that looks like is just a line down your equal sign. It's a mirror to remind me that whatever you do to the left-hand side, you do to the right-hand side. Now, step 2 says to do the inverse operation of the constant to both sides. Now, my constant is always going to be on the same side of the equation as my variables. So it's not going to be -1. It's going to be the -6. Now here's what's important. I have a minus 6, so I have to do the inverse. So to undo a minus 6, I have to put plus 6. So I want you to put plus 6 right below it. And then I want you to do the same thing to the other side. Here's a note that I want you to write yourself. Write the operation. A very, very common mistake that students make here is they don't put the operation. All they put is a 6 there. Now, I don't know what you're doing with that 6. Are you adding 6 or are you subtracting 6? Because if you subtract another 6 from there, you're going to get x minus 12. Now x is still not by itself. You need to put what you're doing. And here's another issue. They don't put what they're doing on the left-hand side, and then when they go to the right-hand side, they write down the wrong operation. So make sure to put what is it that you're doing. You're adding 6. That is so, so important to put there. Now, if you look, these should be inverses of each other. If this says minus, this needs to say plus. If it said plus on the top, then it needs to say minus on the bottom. They have to undo each other. So I have minus 6 plus 6. That equals 0. So what I'm going to do is I'm going to put a line there to show that they cancel each other out. And then I'm going to bring down the x. So I'm going to put bring down what's left. Well, if this is just x with plus 0 or minus 0, that 0 doesn't matter. So all we have left is x. And I'm going to write my equal sign. And now I'm going to solve this. I have negative 1 plus 6. Now, those have different signs, so I'm going to put that different signs, subtract. Okay, now that we could do mental math. 6 minus 1 equals 5. And there are more positives. There was 1 negative, 6 positives. So I'm going to maybe make that note. More positives. So I get x equals 5. That's what your answer should look like. When you're done with this, it shouldn't just say 5. And you shouldn't just put a 5 here and then never do anything else. You need to actually write x equals 5. Okay, and then step 3. I'm going to check it. Like I said, that's what's awesome about equations is you can check your answer. So it's just like in your homework. Like your homework will say, evaluate 3x minus 2 plus 6x when x equals 3. That's the same thing here. We're evaluating it. But instead of x, you're going to use your answer, x equals 5. So what you do is you write the side of the equation that has the variable, but instead of variable, you put parentheses. So I'm going to put parentheses minus 6. I'm going to put equals negative 1, and I'm going to put a question mark above my equal, because I don't know if that's what it equals. That's what I'm finding out. That's what I'm trying to find out. Now I'm going to draw myself a little arrow here, and I'm going to put replace x with, that's what the w slash means, replace x with variable. No, I'm sorry, with answer. So instead of x, I'm going to put 5. And then I'm going to solve that. So 5 minus 6. Well, you can't subtract 6 from 5, so we're actually going to have to do ATO here. So I'm going to switch colors. So that means keep, change, change. So I'm going to change this to adding, change that to a negative. So 5 plus negative 6. Oh, look, those have different signs, so I'll have to subtract. 6 minus 5 is 1, and there was more negatives, so I get negative 1. Which is what I was supposed to get, negative 1. If you don't get negative 1, that means your answer is wrong. Okay. Now, what I'm going to write, do not write this down. Let's pretend a lot of you maybe thought the answer was 7. Because you thought, oh, 7 minus 6 is 1. Done. So let's pretend, again, you're not writing this. Let's pretend that you got x equals 7. So here's what would happen when you do your check. I'm going to put parentheses minus 6 equals negative 1. And I'm going to replace the variable x with 7. Okay, well, now I'm going to subtract. 7 minus 6 equals 1. But look, it was supposed to equal negative 1. That tells me that my answer is wrong. Okay. All right. Now, remember your notes should have been glued into the right-hand side, and the left-hand paper should be blank. Okay, so now in that blank paper, you're going to do this problem. This is not in your notes. So what I want you to do is I want you to pause the video and take 1 minute. It shouldn't take you more than 1 minute to do this. And make sure to check your answer. Here's a couple of things to focus on. Focus on what operation is going on right here. Think about what would be the inverse operation of that. And you're going to do that to both sides. Even if you think this is math to math, I want you to get the practice of doing it with the steps. So whatever the inverse of that is, do that to both sides. When you get your answer, check it. Go ahead and pause the video and do that. Okay, we're going to go over it very quickly. The operation we have here is x minus 5. So the inverse of subtracting 5 this time would be to add 5. Oh, sorry, I skipped step 1. I'm going to draw my mirror. Always go back to the steps. But that mirror is there to remind me if I add 5 to one side, I have to add 5 to the other side. Make sure you put plus 5. Don't just write a 5 there. Now, make sure a negative 5 plus 5 equals 0. If they don't equal 0, then you're doing the wrong operation. These should be opposites of each other. They cancel each other out. Now I'm left with is x. So I'm going to bring that down. Now on this side, I have negative 1 plus 5. Those have different signs, so I subtract. 5 minus 1 is 4, and there were more positives, so I get x equals 4. Well, now let's check that. So I'm going to put parentheses, minus 5. Does that equal negative 1? So I'm going to replace x with 4, replace it with my answer. I have 4 minus 5. I can't subtract 5 if I only have 4, so I have to do ATO here. And 4 plus a negative 5, different signs subtract. So if I subtract those, I get 1. And there were more negatives, so we get negative 1. So our answer is correct. Okay, now still, again, this is not in your notes. This is on the blank page. I want you to do this one. This one looks a little tricky because you have a minus 8 there. Here's what I want you to focus on. Okay, so right here, when we did this top one, instead of subtracting 5, we added 5. So this is saying, this top one is saying x minus some number. So the inverse would be plus some number. Okay, in this case, it's the same thing. Instead of subtracting some number, you're going to do the opposite of subtracting some number. That some number just happens to be a negative 8. Okay, so be careful with that. Go ahead and pause the video and try that. Okay, so let's go over it. So we have x minus some number. The inverse of subtracting some number would be to add some number. Okay, well, some number just happens to be a negative 8. So I'm going to do that to the other side, plus a negative 8. Now I have negative 1 plus negative 8. Same sign, add and keep. So I add those and get 9. I'm going to keep the sign. And I'm going to bring down what's left. X equals negative 9. Now I'm going to check that. I have negative 9 minus a negative 8. Does that equal negative 1? Okay, well, right here I have to do ATO. So I'm going to change. I'm going to keep, change, change. I'm going to change colors here actually to show you the difference. So keep, change, change. I have negative 9 plus 8. Now they have different signs, so I subtract them and get 1. And there was more negatives, so I get negative 1. A common mistake, or actually, let me give you another way you could have done this same problem. Again, there's a different way to do this. Here's what you also could have done. You could have done ATO first. So if I do ATO first, I get keep, change, change. So keep, change, change. That is just x plus 8 equals negative 1. I'm going to draw my mirror. The inverse of adding 8 would be subtract 8. Those cancel out. I'm going to bring the x down. Now I'm going to put minus 8. Well, right here, I'm going to have to do ATO. So I'm going to keep, change, change. Negative 1 plus negative 8. Remember, when we did it the other way, that's what we did. We added a negative 8 to each side. That's essentially what we ended up doing anyway. Same sign, add and keep. We still get x equals negative 9. Again, so you see how that's a little hard to do mental math. That's why I want you to make sure you're doing it this way so you know how to do it with any problem. Okay, this is example 2. This does go in your notes, so make sure you're writing this down in your notes. Okay, we have z plus 3/2 equals 1/2. Go ahead and write that down. Okay, step 1. I'm going to draw my mirror. Now step 2 says to do the inverse of the constant to both sides to isolate the variable. Okay, well remember constant is the one with no variable. You want to get rid of that first. It's like the friend that's constantly annoying you. And it's always on the same side as the variable. If we're going to get z by itself, bringing this negative 1 over to the left-hand side, that does nothing. That doesn't help. All it does is bring more people in. We want to be alone. So we got to get rid of the 3/2. So I'm going to erase that marking. Now take a look at what we have here. We have z plus 3/2. Inverse operation. Inverse of adding is subtracting. So instead of adding 3/2 right here, I'm going to put, the inverse of adding is subtracting. So I'm going to put minus 3/2. Okay, if I have plus 3/2 minus 3/2, that equals 0. Notice again, I wrote what operation I'm doing. And now my mirror reminds me to do the same thing to the other side. Now over here, this equals 0. That cancels out on the left-hand side, and all that's left is z. So I'm going to bring down what's left, z. And now on the right-hand side, okay, we're subtracting fractions. They're supposed to have the same denominator, and they do. They both have a denominator of 2, so all we have to do is add or subtract the numerators. But I have 1 minus 3. You can't do that, so we have to do keep, change, change. So keep, change, change, or add the opposite. So I have 1 plus a negative 3. Those have different signs, so we subtract. If I subtract 3 and 1, I get 2. And there was more negatives, so it's going to be a negative 2, and our denominator stays the same. Okay, now that's not simplified. But step 3 says to check. Here's the thing. If you look at our original equation, it has a fraction in it. So if I'm going to check it, I need to keep it in this form in order to check it. So don't simplify until after you check. Let's write that. Simplify after you check. Alright, so I'm going to write that here. So instead of z, I'm going to put my answer, negative 2 over 2 plus 3/2. Does that equal 1/2? If it doesn't, my answer is wrong. So, okay, we have the same denominator. That's good. We're going to add and subtract. We're going to add or subtract only the numerators. So negative 2 plus 3. Different signs, so we have to subtract them. 3 minus 2 equals 1. There are more positives, so it should be a positive 1, and we get 1/2. Now that that's correct, now I'm going to go back and simplify. So negative 2 divided by 2 is 1, so we get negative 1. So z, whoopsies, I should not have done that. Z equals negative 1. If you have space, you can actually just write it below. You could write z equals negative 1. Okay. I want you to try this one on the empty page. So this goes on the left-hand page. This is not example 3. So I'll start you off. Go ahead and draw your mirror. So kind of do it as I go along. You have W plus 13.2 equals 10.4. Now here's something to think about. Think about what operation this is. Remember, you want it. If we want W by itself, what number do we want to get rid of? 13.2. Well, right now we're adding 13.2. So the opposite would be to subtract 13.2. So go ahead and put subtract 13.2 from each side. Plus 13 minus 13, that cancels out. All you're left with is W. Now, on the right-hand side, here's where it gets tricky. We have 10 minus 13. You can't do 10 minus 13. We have to do ATO. We have to add the opposite. Okay, now looking at them, we have a 10 and a negative 13. Those have different signs. Subtract. But here's the tricky part you got to remember. When you subtract these, the one there's more of has to go on top. We have 10 positives, 13 negatives. There's more negatives. So when you do this, the 13.2, do it off to the side. 13.2 needs to go on top. Be careful, you might have to borrow. Go ahead and pause the video and finish. Okay, let's go back. Check your answer. You can't do that, so you borrow. You get 12 minus 4 is 8. Drop our decimal. 12 minus 0 is 2. And that equals 0. And we get 2.8. Now, you got to check your sign. You have 10 positives, 13 negatives. There are more negatives, so we get negative 2.8. Now, let's check our answer. So, if I write negative 2.8 instead of W, so it's 2.8 plus 13.2. Well, those have different signs, so we would have to subtract them. So again, I'm going to do that off to the side. Don't be afraid to write work off to the side. That's what a lot of people, that's what gets them in trouble, is they're afraid to like mess it up or something. So you can't do mental math with everything, okay? So 2 minus 8 you can't do, so we'll have to borrow. It becomes 12 minus 8 is 4. 2 minus 2, oh, sorry, drop our decimal. 2 minus 2 is 0. And 1 minus 0 is 1. And there were more, let's look back at our answer right here. There were more positives, so it's positive 10.4, which is what we were supposed to get. Okay, example 3. This part does go in your notes. It says a company has a profit of $750 this week. Now, a profit means how much money that company made. And it's not just however much they sold. Let's pretend that, for example, you own a restaurant. The profit is not just however much everybody pays for your food, because you have to pay for the restaurant building, you have to pay for all the utilities, you have to pay for all the food, all the equipment, and then of course you have to pay your workers. So even if you sell, $7,000 worth of food, maybe you didn't make $7,000. Maybe you actually only made $1,000 because of all that stuff you have to pay for too. So profit means, maybe we should write that, money you earn. Now, if it's just talking about a job and they pay you, $2,000, that's your check, that's your profit. Okay, what you choose to do with it, that's different. But with businesses, it's a little different. So as a company has a profit of $750 this week. So I want you to circle your numbers, 750, and I want you to underline, I want you to box any keywords. Well, that $750 is for this week. That's important. That's a keyword. So we're going to box that in. Okay, now it says, profit, that's a keyword too. This profit is $900 more than the profit last week. Okay, again, we're going to circle our numbers. and we're going to box the key words. Well, more than. More than is a key word. More than means what operation? It means plus. Again, profit last week. That's the profit last week. Okay. Here's another keyword, profit. Here's something that you should know. Most of the time, and it's not every single time, but most of the time, the word is means equals. Like if I say 3 times 2 is 6, that's the same as 3 times 2 equals 6. Okay. Now, some of you, if you notice the directions, I typed this wrong. It should say write and solve an equation to fit the expression. One way to solve a problem is to use a verbal model. So kind of write it out first. So that's kind of what I did for you here. I wrote it out for you first. I want you to fill in the blanks because you're missing some of those words. It says the profit this week is $900 more than the profit last week. That's what we know. So we're going to break that down in order to write an equation from this. Well, let's look for our key words. We have this week. Now look at what we wrote up here. A company has a profit of $750 this week. Well, the profit this week, so that's $750. Is, that was our other keyword. Is, again, means equals. So $750 equals $900. So we're going to bring down $900 more than, well, we said that the word more than means we're going to add more than the profit last week. Well, let's look back at what we have. The profit last week, well, it tells us profit P. We don't know. That's what we're trying to find. What was the profit last week? We don't know, so we're going to put P. Okay, so we're going to draw our mirror. And we want P by itself. Well, you're like, well, isn't it usually on the left-hand side? Yeah, usually, but it doesn't have to be. Same thing here. P happens to be on the right-hand side, but you still want it by itself. So that means you got to get rid of the 900. Well, maybe some of you are thinking, well, there's nothing in front of the 900. Well, that 900 has what sign? It's positive. A positive P is the same as adding 900. So if you have 900, how do you get rid of it? That's right, you should be subtracting. So subtract $900 from each side. Go ahead and pause the video and solve that. Okay, let's see what you should have gotten here. 900 minus 900 is 0. That's what we want. That way P is by itself. 750 minus 900. You can't take 900 if you only have 750. So you have to do keep, change, add the opposite. Some changes to adding, and the opposite of 900 is negative 900. Those have different signs, so you subtract. But there's more negatives, and if you can't do that mental math, then you have to set it up with 900 on top. So you should have done this off to the side. 0 minus 0 is 0. You have to borrow here. 10 minus 5 is 5. 8 minus 7 is 1. So, and there were more negatives, so you get negative $150. Now, what does that mean? If P equals negative 150. If their profit is negative 150, that means they lost money. Not like they can't find it, like they spent more than they earned. Which, if you own your own business, that happens a lot, especially when you're first starting out, when things are slow, or certain companies have a slow season. Like if you fix air conditioning in Arizona, you're not making a lot of money in the winter times. You have a negative profit as a company, but in the summertime, you're making tons of money because we're very dependent on our ACs here. Okay, one more example for your notes. It says a line graph shows the score while you and your friend played a video game. Write and solve an equation to find your score after level 4. Okay, so here are our levels. Here's level 1, 2, 3, and 4. So this is what we want right here. Okay, now take a look at what it tells us. Tells us your friend's score is 33 points less than your score. Again, writing it out in words is so helpful. Okay, look, it says your friend's score is, oh, what does is mean? Equals. Okay, equals 33 points less than your score. Okay, so let's take a look at this graph over here. This 33, that's not how much points you have, and that's not how many points your friend has. That means that is the difference between your score. That means somebody won by 33 points. There's a 33-point difference in your scores. So let's put a minus sign. Okay. Now, we have your score and we have your friend's score. You are right here in the green, so you kind of started out bad and then you got a lot better. Your score is right here. It doesn't tell us what your score is, but we do know what your friend's score is. Your friend's score is right here. It tells us this is the level, so level 4, and they ended up with -8. So right here, your friend's score is, well, we already know what their score is. It's -8. Now, we have two options for the right-hand side. We could put 33 minus your score. We're just going to call that S. Or we could do S minus 33. Don't write this down yet. We could do S minus 33, or we could do 33 minus S. Now, think about this. Here's what's tricky. It says your friend's score is 33 points less than your score. So whatever your score is, theirs is 33 less than that. So let's take a look at this. This says that we take your score and subtract 33. So this says we take your score and subtract your score. It should be this first one, because look at the sentence. Your friend's score is 33 points less than your score. Well, here is your score, S. We want 33 points less than that, so it should be S minus 33. Again, that says your friend's score, -8, is 33 points less than your score, and your score is S. Now start with something in mind. Look at the graph. Here's 20. Here's 30. Your score should be somewhere between 20 and 30. We can't quite tell. Maybe it's 23. Maybe it's 26. We don't know. Well, we're not going to guess. So we're going to draw our mirror. That's not very straight. Sorry. And now we have S minus 33. So we have minus. So the inverse of subtracting 33 would be to add 33. Make sure you put plus 33. Now my mirror is there to remind me if I add 33 to one side, I have to add 33 to the other side. So I have minus 33 plus 33. Those cancel out and we get 0 there. But we still have S. So I'm going to bring down what's left, S. Now on this side, we have -8 plus 33. They have different signs, so we're going to subtract them. But when we set it up, we have to put 33 on top. So just do it off to the side. So just put 33 minus 8. I'm going to have to borrow. That becomes a 2. That's 13 minus 8. Should be 5. And 2 minus 0 is 2. And there were, let's look back at the problem. There's more positives. So 25. Look at our estimate. We said it had to be somewhere between 20 and 25. That should be correct, but we're going to check anyway. So -8. Does that equal your score, S, 25 minus 33? Okay, well, if you have 25 and you subtract 33, we can't do that. So you have to ATO. They have different signs, so we subtract 33 minus 25. You could just count up from 25. 26, 27, 28, 29, 30, 31, 32, 33. That's 8. And there was more negatives, so we get -8. Now, don't write this down. Let me show you what happens if you had done this equation instead. Again, don't write this down. I'm just showing you. So if you had said negative 8 equals 33 minus s, let's see what happens. Well, that's a positive 33, so the inverse of adding 33 would be to subtract 33. 33 minus 33 is 0. That's what we want. I'm sorry, that should be an S, not an 8. Again, you're not writing this down. Those cancel out, so I'm actually left with a minus S. Left with a negative S. And on this side, I'm going to put minus 33. Okay, negative 8 minus 33, I'm going to do ATO. So keep, change, change. Negative 8 plus negative 33. Those have the same sign here, so we'd actually do same sign, add, and keep, and we would get negative 41. That doesn't even make sense. That means that the opposite of S, the opposite of your score is negative 41. So, well, the opposite of negative 41 would be 41. But look, 41 is like way up here. That's like way off the charts. Over here. Your score is nowhere near that. That answer doesn't make sense. So, always use the graph to give you an estimate. Don't do it, just guess your score off of that. But use it to help you estimate. And you're going to get a worksheet. We will be playing Kahoot, but because it's timed, I don't want you to just guess, so I'm going to give you some time to do the answers on your own first. That when we get to Kahoot, you'll already have your answer ready to go. So this video is over, and go ahead and do the worksheet.